My name is Latimir Rangiov, and in this presentation I'm going to demonstrate my contributions inside the procedural city generation group project. I will expand on the WaveFunction collapse used for the creation of the roads. To get the WaveFunction collapse to work, a blueprint actor child derived from the C++ file needed to be placed inside the level. The actor needed to be raised up slightly as to not spawn the roads inside the ground mesh. The road algorithm works only in runtime. For this demonstration, sample buildings were used as to speed up the process with less calculations and to demonstrate the general idea of what the project is supposed to look like. On the left side of this editor, there are three very important settings exposed to the editor: the X and Y positions, and the seed. The seed takes a set seed and generates the road from it. A seed was used to give the user more control over the generation. This way you can set the seed, and every time you press play, the same generation will be built every time. I will demonstrate what will happen when you change the seed. There is a caveat when it comes to the grid size as well. When the grid size is changed, the road will have different generation regardless if the user has changed the seed or not. Another important part exposed in the engine is the road segment prototype. This is a struct containing all of the variables necessary for the in-engine customization of the algorithm. The road segment type is a list of segments that are used inside the procedural road. The mesh actor takes an actor blueprint. This was done because changes need to be done to accommodate the other team members. For example, the road needed a spline for the AI car, and additional logic for the traffic system which is not yet implemented. And the building generator are also using an actor blueprint to run the logic. The rotation is used to rotate the actors for each individual segment. The sockets are representing the X and Y axis. Each of these axes has its own sockets. The WaveFunction collapse looks at each of the sockets and connects matching ones. For example, 1 connects to 1 and 0 connects to 0. The way determines the likelihood of a segment to spawn. The higher the number, the more likely it is that the segment will spawn. In this example, the straight road segment are set to 8 and the vertical straight roads are set to 7. When the weight is changed to something like 1, it will reduce the number of these two segments, and the road will look something like this. And if the number is 20, it will look like this. Now I'll demonstrate how the seed works. Each time the seed is changed, the road will generate a new and unique pattern. And now I'll demonstrate how the rotation works for the segments. The number of the rotation corresponds to how many degrees the mesh is rotated by. The next thing I'll demonstrate is the socket connection. I want a connection to the segment where it does not follow a coherent road's logic. The demonstration shows that the road segment do not follow the usual road rows. These arrays hold all of the road segments necessary for each creation of the road. The list contains straight roads, turns, and T-junctions. The road is supposed to work with procedural buildings, but when the procedural buildings are added to the wave function, they take a while to spawn. This is a speed up of the spawning process. The wave function works by creating structures through iterative entropy reduction, starting with a grid of cells each with multiple potential states. The wave function selects a cell based on the lowest entropy, collapsing them into a single state. Each of these decisions influences the neighboring cell's process, repeating until the whole grid is collapsed. The wave function collapse in this project works as intended, making mostly realistic-looking roads with buildings surrounding them. There are some areas for improvement. For example, the roads could be more refined and realistic. Some of the roads spawn in positions that do not make sense in the real world. Another area for improvement is the edges of the grid. Some of the roads point outwards. This is not ideal for a project like this, as there is an AI element, for example the AI car, and some of the roads could lead the car outside of the grid. This is the end of the presentation.